Alright, hi. So this is basically a video that in which we highlight the various core functionalities which the Vision Focus Group developed this semester. So this is a comprehensive README that essentially lists all the core functionalities that we've come up with, and there are separate documentations for each of the packages. So if you want to know more about them, you should look at the individual README files. So the first thing that I want to talk about is basically the core functionalities that we developed. The main ones are object detection on the Movidius neural compute stack, scene recognition, face recognition, and vision handler. I'll talk about what each of these do in the next few minutes. Before that, let's take a look at the vision pipeline. So essentially what we wanted to do was come up with a pipeline which is raw spaced, extensible, and as modularized as possible. The main reason we wanted to do that was that vision is a very fast moving field, which means most of the state of the art algorithms today are going to be obsolete in a few months or maybe a year. So we wanted to come up with a pipeline which using which it's very easy to swap out algorithms, but at the same time ensure that things proceed the way you want them to be. So in this case, the vision pipeline takes in RGBD images, and this year we use the Kinect for that. And then the first layer is the vision handler layer, where we have a module called the vision handler, which is essentially like a middleman. Using the vision handler, you can set the frequencies of all the packages. Essentially, you can set how fast or slow they need to be executed. Next comes attribute layer 1, which uses the topics published by the vision handler and makes use of them and publishes new topics. Attribute layer number 2 uses topics published from vision handler and attribute layer number 1 to come up with more intelligent attributes. And attribute number 3 takes topics published from the preceding layers. So essentially, as you can see, the pipeline is in such a way that using low level attributes over a period of time, you can come up with higher level, more meaningful and intelligent attributes. Now let's take a look at what each of these modules do. The first one is object detection. The name of the package is .NET ROS interface. This essentially detects objects in a given image using the YOLO v2 object detection network. As of now, this is one of the most real-time object detection networks that also performs really well. This is a wrapper package around an already existing ROS package called the .NET ROS package, and that wraps around the source YOLO v2 object detector files. The next one is object detection on the Movidius neural compute stack. So this year we used an Intel NUC for as the core processing unit, and this made things pretty slow for deep learning algorithms. So we looked into using portable deep learning or computing devices, and we came across the Movidius neural compute stack. So as of now, the neural compute, this package can only execute the tiny YOLO object detector. There's more about this on the README and in the focus group report, but essentially Movidius neural compute stack has very little documentation, and as of now their model zoo is pretty limited, and it's really hard to compile our own algorithms to fit their SDK's requirements. So as of now, only tiny YOLO has been successful, but hopefully when you guys use this next year, more things are at play. The next package is scene recognition. The name of the package is scene recognition. This package is essentially a ROS wrapper for the Places C365 code that was released by CSAIL from MIT. So essentially, the code classifies an image into one of 365 scene categories, and you get to choose the architecture which is used to do that. And we went with ResNet 18 because it was pretty robust and it gave really good performance on the Intel NUC. It ran at approximately 9 FPS, which was more than enough speed for a scene recognition algorithm. we made one key modification to the code. The code, as you can tell from the name, classifies a given image into 365 categories. We modified that to output one of 5. These 5 were chosen because these are the most common scenes that you would see in the engineering building. So, but then we've provided instructions on how to modify this for more classes or less classes. The next package is face recognition. The name of the package is facial recognition. This detects faces in a given image using the Python face recognition library. So essentially, what it does is it detects faces in a given image using dlib, and then it warps the face to form as close to forward-facing faces as possible, and then it runs that through a pre-trained neural network, essentially computes feature encodings, and then it uses an SVM on top of that to classify a given face as into their labels. So it works pretty well. It's pretty robust. We haven't actually tried for more than, I think, 7 or 8 faces. So that's one thing. We're not entirely sure right now how it's going to scale, but it's really easy to use and it's robust. So you guys should definitely start from this point. And of course, the vision handler, which I mentioned before, it essentially provides the functionality for clients to change how often each package runs by changing their frequency. As of now, we've written service calls for object detection, face recognition, and scene recognition. It's pretty easy to use, it's well documented, and you can write more service calls for more packages that you develop in the future. The one main key point that I would like to stress is to read up about the vision pipeline in the README and in the focus group report. I haven't explained too much about it here, but it's pretty well structured to learn from low-level modules. It's a bottom-up approach, and it would be nice to take a look and see if you guys can integrate future packages into this. That's about it. Thank you.